All right, what's up, everyone? I'm going to try my hand at making this video. Is going to maybe give you an easy explanation about how to get through this lab that we worked on uh, last week. All right, so I've already downloaded the data set. Everyone seemed to understand how to do that pretty easy. What I want to do is I want to change this to SMin, change this to SMax. Oh, and I think everyone pretty much understood that's what we were doing. Next, I want to insert a column. So select the column, right click, insert, and we're going to label this one S mean. Mean is the same thing as average. It's just kind of what we use in scientific terms. And then we're going to label this one T mean, because T mean is what we're going to use for calculating our growing degree day 50. So in cell K2, we're going to click auto sum. And because mean is an average, I'm going to click average. I want to make sure that I2 and J2 are selected, because that is the range of cells that we want to take the average from. Enter there, select the cell. You can double click the little box to flash fill. We're going to do the same thing in cell N2. Make sure that we have the right range selected. And we'll bring that all the way down. Next, I want to select this whole table. And we're going to try for find and select. If you can't find this in your ribbon, you can go to File, Options, Quick Access Toolbar, and you can search for it in either there or Customize Ribbon. This is where you would find that at, though, either in Quick Access Toolbar, probably because I've already got it in there, maybe for a different video if you can't find that. This part isn't too super important, but it is pretty cool to do. So you want to find and select. I'm going to click Go to Special. We want to find the blanks. I'm going to click OK. And so then immediately you want to type the value that you want to go into this blank cell, just once. And so for us, we want 0. Then at the same time, we are going to press Control and Enter, and it will fill the rest of those blank cells with whatever value we typed into the original cell that it asked us to start with, which was G2 in this case. All right, now that we have that, what we're mainly looking for is growing degree day. So we're going to make this, we're going to label this column growing degree day 50. And this is a simple formula. Remember that our formula is the temperature max plus the temperature minimum divided by 2, which gives us our T mean minus 50. So this is equals, we want N2 selected. You can either hit the arrow, you can either hit the left arrow, you can select it with the mouse, you can type it into the bar, minus 50. N2 minus 50. Click Enter, select our cell, we'll flash fill everything down. Well, the problem that we have is that if the it's not a positive and negative system. Growing degree days are not calculated on positives and negatives. We only get accumulation for those days when the GDD 50 is above 50. So let's make this GDD 50 underscore 1. Next, we're going to do an if-then function. If all right, our logical test is if O2 greater than 0, we want it to be a positive number. If O2 greater than 0, value, if true, then O2. And so we will just type O2. If not, 0. So our function, we want to do an if then. When our box pops up, O2 greater than 0, O2. That is the value that we want if it's true. If it's false, 0. So because our O2 was negative, it gave us a 0. We will flash fill. And we can see that on a few of these days, we've gained some growing degree days, but not consistently. We wouldn't typically find our growing degree days consistent. I'm sorry, I need to back up a moment as well and do this for the date. So I don't think this makes a big deal. I just like my dates to be a specific way. So we're going to have our date column selected, number format, date. So select the date column, come up here to number in general, click the drop down box, date. We're going to select 14-mar. Click OK. That formats all of our dates for us. We know that the year is 2021. And we can also put that in our graph if need be. So one of the requirements for planting is that, let's come back up here. We want to go to View, Freeze Panes, top row. View, Freeze Panes, top row. And just like the name says, it's going to freeze the top row. So now we're able to look in column I, and from our sheet, it says that the minimum soil temperature should be greater than or equal to 55 degrees Fahrenheit for 3 days before corn is planted. We know it's not going to be above 55 anytime in February. Maybe in April we start to get some. So we'll look at April. We need 55 degrees for 3 consecutive days. And we see we have 3 consecutive days with the temperatures above 55. So our planting date would be May 1st. We're just going to go ahead and bring this on out over here. We know that our planting day is going to be May 1st. So we're going to create a new column. It's already created, so it's not like we have to insert it, but we are going to label it GDD 50 underscore date 1. You can make it May 1. I'm not overly concerned with the column headings as long as they make sense. So growing degree date, date 1, we know that we're going to start on the day that we planted, and our formula for cell Q122 equals P122. But growing degree date is an accumulation of those, heat units. So our new formula is going to be equals. We can click up, the up arrow to pick Q122 plus, and then hit the left arrow. You can do this with the mouse if you like. If you know what the cells are, you can actually type them into the formula bar up here. You can either click on them, you can use the arrow keys, or you can type it into the formula bar. The choice is yours. I'm not going to tell you you have to do it a certain way. I tend to use the arrow keys because it's simple and easy. Click enter, and we're going to flash fill all the way down. And you can see that our degree days are starting to accumulate. So the questions for table 1 are, we know that it requires 125 growing degree days for our plants to emerge. So we will scroll down and look until we get to 125. We know that on 19 May, we can expect our plants to emerge because we need 125 of these growing degree days in order for that plant to finally emerge out of the ground. Next, we're looking at V6. So V6 requires 470 growing degree days. We'll scroll down. It looks like this is going to occur on June 11th. Next, we have V12, which occurs at 815. It looks like this is going to occur on June 28th. For V18, we need 1160. Somewhere between July 14th and July 15th. R1, we need 1250. So about 4 days later, on July 19th. And then finally, we need 2,350 growing degree days to reach R6 or physiological maturity. 2350. So somewhere about September 8th, September 9th, we can expect to reach physiological maturity. We'll begin walking through the field, checking for black layer, which is our indicator of physiological maturity. The plant is not taking up any more nutrients at that time. It is done growing. After this, we're just waiting for the dry down. Everyone understanding kind of how I'm getting that? Where this tool can become useful is if we have a problem that kind of shifts our date. So we knew that we were going to plant somewhere around May 1st. Well, let's say you go to plant May 1st and there's a tractor malfunction and it takes 3 days for the parts to arrive. So May 1st, somewhere on May 4th, it's raining about 1/2 inch and it rains for the rest of that week. And we can't get in the field, so it's going to take a while. And now our planting date is likely to be shifted back to, gave you that date, May 15th. So we're going to come for May 15th. See if I can zoom that in some more for y'all. On May 15th, this is now going to be GDD 50, date 2. Or if you like, you can use May 15th. So here we are, May 15th is our new planting date. We'll go ahead and highlight that in a new color. And we'll use our same function. So equals, we'll hit the left arrow. So we know that that's the day that we planted. It's going to take 125 growing degree days accumulation. This is equals, I'm sorry, our growing degree day is in column GDD 51, 50_1. See, that's why it pays attention. That's why it pays to know which column you're going to be in. So this is where we gathered that from. I'm going to highlight that a little bit darker color from this column. And then our next formula will be equals. Going to equal this column plus this looks like P137. P137. We'll go ahead and flash fill that all the way down. And just like before, we will search for when our growing degree day accumulation is greater than 125 for emergence. That is going to occur on somewhere about May 24th. Just going to use this color. Next, we're looking for V6 at 470 growing degree days. Let's scroll down somewhere around 14 June. Next is 815 growing degree days. We see that around July 1st. V18 at 1160. And then R1 at 1250. Still about another 4 days later. I'm going to zoom out for a moment. What's interesting to note is that even though we're 2 weeks late planting, or almost 2 weeks late planting, this was our original plant date, May 1st, and this is our new plant date because we had that tractor malfunction, that even that 2 week difference is not really going to cause much of a shift in our management practices. So, sticking to hard, I'm planting on May 1st, there may or may not be some advantage to that. In this case, it doesn't look like there is because we didn't accumulate a whole lot of growing degree days in that 2 week period, mainly because it was raining. And then finally, we're looking for 2350. I'll zoom this in a little bit so we can look better. We're looking for 2350 somewhere around September 14th. So a 2 week shift in planting date really only caused us about 4 to maybe 5 days in a difference in when we maybe harvest or when we fertilize. Growing degree date is used so that we can begin to schedule certain agronomic practices. All right, everyone kind of understand what we're looking for there. Now I know in the exercise it said to remove a lot of dates. I'm going to go ahead. Let's zoom over. So in column A, Control Shift over, Control Shift down, Control C, page up. Let's put this in cell T1. We're going to want to paste the values. We don't want the formulas in here anymore. We just want the values because we're going to be deleting some things that are just kind of unnecessary that we don't need. So we want to select our whole table or our whole at least data range, and we're going to paste it into cell T1. Next, we want to come over to column Y. We want to format, more custom format, date, change that back to 14 March. Click OK. That formats it the whole way down. Now, since we don't need pretty much everything before May, let's just make this, let's just take this to April 1st. All right, so we're going to select all of that, right click, delete, shift cells up. All right, so we got everything from April 1st. Let's move down here and we will delete everything after, where did we make it to? Where did we make it to? September 14th. I think I kept it into October 31st. So let's go ahead and remove everything from November 1st down. Delete, shift cells up, not that it's going to matter. I just left October in because it might be, what if we planted cotton and that growing season extended into October, maybe even early November? The other things that we can get rid of are station, name, latitude, longitude, elevation. So columns T through X can just delete them. We don't need them as far as what we were trying to do. Other columns that we don't need are GDD50 and GDD50 underscore 1. Let me open these up. You can select all your columns and then put your cursor. Notice how the mouse becomes kind of a line with an arrow going left or right. That what that does is that expands the cell wide enough for whatever the column heading is to be seen. So we know we don't need growing degree date 50 or growing degree date 50 underscore 1. This is why we pasted the values, because if we were to delete these columns, we would also lose our growing degree date in here. Delete those, and we still have our values. For demonstration's sake, for demonstration's sake, this is what happens if you just control paste. So we know that our growing degree date 1 starts here. If we were to delete just these two columns, and now we don't have any values, we've just deleted the references for the formula. So if you're going to be deleting columns, make sure that you paste just the values if you have formulas in there. I'm going to hit Control Z. That brings everything back to where it was before. All right. I guess since we're really not doing anything in April, I'm going to go ahead and delete those as well. You can either right click and delete. Me, I like to use Control Negative, Shift cells up. Let's go ahead and take out October. We would expect that if our plants reach physiological maturity sometime in the middle of September, we don't need those anymore. Control Negative, Shift cells up. There. Now we have a new data set that gives us all the growing degree days for the time period May 1st through September 30th. And I know it asks how many growing degree days accumulated total. Let's just say that from May 1st to September 30th, we accumulated 2,583 growing degree days. Everyone following kind of how that is? Not, you can go back and watch the video a little bit slower. Next, what we want to do is we want to summarize this data. And so we are going to, let's do this. Control, we're going to select T1. Control, Shift, right. While still holding Control and Shift, you can click down. That selects the whole table. Let's bring this all the way back to the top. And we're going to insert a pivot table. It will ask you, it will tell you this is the range from the table that we're looking for. We're going to click Existing Worksheet. So insert, pivot table, existing worksheet. Our location, let's go ahead and put this, I tend to like to put mine one column over and one cell down. So instead of putting it in AF1, I would like to put it in AF2. That's where our table is going to start. Click OK. It's going to bring up this pivot table field. And so what pivot tables are really good for is being, as you saw in the, you might have seen in the explanation, is we can really take a large table and pull out only the data that we care about. So we at least want the soil min, max, and mean. And we want temperature min, max, and mean. And we also want precipitation. And we need date. So date is going to be, and most of this will populate it for you, so you don't really have to figure out what it is you want to do, but we could put the date over here, and then our values would be set out on a big long table like that. That's not what you want to do. So we want to put our dates back in our rows. So the date is in the row, and this basically summarizes everything for May. So if you really wanted to, you could look in and see what the value is for that particular month. But what we want to, this is going to, let me see if I can move this, make this larger so you can see what I'm doing. So the sum of S min. So what it did is it summed all the minimum temperatures throughout the whole month. And that's not what we want. We want the average of the minimum temperatures. One bad thing about pivot tables is that you have to recreate the new column name because S min already exists somewhere else on the sheet. So we need to change that. We don't want to have this big long table, this big long column heading. So I'm going to label this soil min. Notice that it changed the heading right there. We'll need to do this for S max, average, you don't have to put the underscore if you want. You can label it however you want to, but that's a pretty good way to keep everything kind of straight. This is for okay, and we'll do this for Tmax. Min. Temp mean. And we want to make sure that we leave the precipitation as the sum, because we want to know what the total rainfall is across the whole growing season. And so we can just change this to rain. Precip. I'm not going to get too overcomplicated in the names of the columns. I tend to prefer 2 decimal places, so I'm going to select the whole table. I'll come here to number, and I will change the number of decimal places to 2. And I'll also tend to prefer all of my stuff centered. So everyone can kind of see. So in data visualization, I asked you to complete the table below. You would fill in the min, max, and the mean for soil. So the min is 59.29. Wait a minute, this is over. This question is asking over the whole growing season. So the average is the minimum soil to the average minimum soil temperature over the growing season was 67.83. The max is 70.39. The mean. What I didn't like about the way that outputted the data was we had soil min and max, and then we had temp max and min. What I'm going to do here, well, it's not going to zoom in. What I'm going to do is I'm going to move max and min, and that changes that in my table. Again, that's a personal preference. I don't care where you put that. As long as you fill out the table correctly, that's all that matters. So our temp min 58, temp max 76, and the mean temperature throughout the growing season 67 degrees. Next, in table 4, I ask you to fill in the rainfall amounts for May, June, July, August, September. We took out October, so there's no need to put that in there. Our growing season total is going to be 22.56 inches of rainfall. Okay, so that should get everyone pretty much caught up for at least getting to the tables and being able to finish the first part of the data visualization. The next part that we're going to get into is how to make the graphs for that. And I'll probably end up making another video just like I did in this one. I think this is going to work out well. All right. Hopefully that helps. If you have any questions, feel free to email me, stop by and ask. I'm always around, here to help. See you in the next video.